Hello, good afternoon. My name is Rafael Alvarez. I'm from a private company called VerdeSmart. We are experts. We have some sensors patented. Our focus is not only using sensors data, but how we transform them into information and knowledge that is useful for the growers. Okay. Okay, so we all know that there is a big problem in the world related with environment and agriculture, which is nitrate contamination in groundwater and rivers. There are all in Europe and United States and developed countries a lot of legislation about how to control nitrate, but the big problem is that we cannot measure it. So the problem is huge. For example, in the United States, we got 10 million hectares contaminated with nitrate problems, and 140 million tons of fertilizer are used every year. So, when we analyze how we take decisions, they are mostly intuitive. If we focus in, If we focus in Almeria, we got, as an example, we have a big opportunity cost related because we all know as growers how we planify and we make our fertilization plan and how we distribute the nitrate during the whole season. But what we find out is that there is a lack of diagnosis indicators. As an example, if we calculate that we have 3,000 to 4,000 euros of hectare of using nitrates in Spain, in Almeria, we all here, they invest close to 70, 80 million euros a year. The example I'm going to use here right now, which is a practical use, is that we could even save and optimize almost 40, 50% of this cost. Okay. Which is the solution? We have developed for the last 7 years. It's a very costly and hand labor project. The first nitrate and potassium sensor that can work in soil conditions, not hydroponic conditions, okay? And which is called the NutriSense. What is the? Okay. So we can measure, it's a point sensor, okay? So with this, what can we do is just quite simple things like we can understand if the plant is uptaking or not, if the nitrate is leached or not, or if we are under or over nitrate irrigation, or to understand if the weather stress is affecting how the plant uptake nutrients. So what we are really measuring, we measure nitrate and not nitrogen forms, and we just measure what is called in English pore water, okay? So, and we are measuring in this area what is, for example, in potassium, obviously nitrate is in pore water, but is the soluble part, okay? So, so what we are proposing is something very practical, which is everybody knows which fertilizer solution and which standard injection radio got. So what we propose is just, for the grower, is just, okay, check and measure what is your concentration of nitrate and potassium in your dripper, and then we have a diagnosis is that you can compare this concentration, what you got in your root zone or your drainage zone. And the action is that you are up on over or down on over, then you can change the way you are applying the injection radio or change your fertilizer solution. For doing that, what we are working is like for a very practical and easy and cheap solution is we are making a proposal using Reason Probe, Lagua-Twin, meter, and our sensor. So based on the work that here Milagros have done for the last years in IFAP and Mojonera, what I think is quite important is that with the Lagua-Twin has a scientific background that is like we got a real-time solution that we can measure nitrate quite easy in my farm from the dripper or from the pore water I extract, okay? Second option, which is quite important to solve, something that we have to solve, is that to calibrate the sensor for each soil condition, I have to extrapolate data if I have to take a very fast decision to change things. And the third thing is that I have to, what is called, I don't remember the third, but anyhow. So this is Drizzon probe, okay, most of it you know. So we propose you install 3 in the same time we install close to the NutriSense, because we are going to correlate the millivolts that we got in our sensor for a 30 minutes extraction with the Drizzon probes, that because with 2-3 millimeters we can correlate, okay? So with that, working with a syringe, we can do it very fast, and each grower can do it, okay, quite easily. So so at the end, the grower only have to do 2 things that everybody knows, the fertilization plant, but no one knows which is the concentration in the dripper. So quite easy. Measure your dripper, what concentration you have every 15 days, and then second, which is very important, okay, using Drizzon probes close to it, you calibrate, and sometimes when you have adapt, you can measure and control in other areas to extrapolate, okay? So I'm going to, here is Paqui, that is Francisca Ferrer, and work we have done in Parkenat, and with working with Ispatec and this platform, Ortisis, an example how to do this, how we can work with that. So the key question here is how we can measure. We must have a target. So we are not telling the grower what to do. So he has his background about, and what we are going to do is to show you first in the root zone, and second, we'll check the leaching and potassium uptake in the root zone. Okay, what is your target? Okay, I'm measuring my dripper, so I realize, okay, I have 11 milliequivalents, so I got that. This is November and December, and what we saw after starting working with that the nitrate was going down 2 points below, so we decided we make a diagnosis and we do an alert, and Francisca and Paqui decided to increase the amount of nitrate. Okay, so because once we did that, so we continue into next months. So at the end, what we keep during the whole season is why the target was to have the same concentration in root zone as he was his best experience fertilizer solution, okay? So that's what he did, we increase, and that's the way we work. Okay, let's see. Another thing which is really important is that we have discovered not only in tomato, because what I'm going to show you here is really impressive, is then in summer we check in viticulture, in olives, in citrus in Spain. What it is that there are some scientific background about that, but we realize, and it's the example I'm going to show you right now, is that when the plant gets stressed, then reduce the amount of nitrate that they are uptaking and increase the potassium consumption. And this we have checked that could happen with salinity, any kind of stress, salinity, water stress, high BPD, etc. And this is quite important to understand what I'm going to show you right now, because this is nitrate at the leaching area. So this is in January and February, 2 years ago, last year. What we got is that we realized that suddenly this is 11, 12 milliequivalents, and we are starting to check that the leaching area is starting to increase, and we realized that we were moving to 17, and when we check temperature, we realized that we are starting to have temperatures below 10 degrees in the greenhouse. So what we decide is just to reduce the amount and Paqui decide to reduce the amount of nitrate, because we were checking there was too much water, but we even 50%, but we keep having leaching. So as in those days we didn't have the reason and we didn't have more diagnosis, it was only 1 point, we realized that, that we keep reducing that. At the end, for the potassium, as you can see here, in those days with low temperature, we realized that the plant decided to uptake more potassium. So we increased the amount of potassium. This is a real-time decision that before is not possible. And at the end, in the whole season, Francisca was checking data, taking decisions, and having working with forecasts, so it was like a feedback. The final result does that we act to maintain and to keep the potassium concentration value and we increase 30% of potassium in the total amount, and we reduce, which was amazing, almost 60% of nitrate. But at the same time, what Francisca get is an 11% better increase of fruit size. And one of the reasons is that, and this is something that we have checked working together with scientific centers in olive, in citrus, and in other crops, is that you all know that the potassium is very important for the backbone, and at least is from a grower perspective that they are going to have 1 hour every day to have more photosynthesis working. And we have several, the nutrition is adapted to several different kind of hardwares. Okay.